The one-way analysis of variance, ANOVA, is used to determine whether there are any statistically significant differences between the means of two or more independent, unrelated, groups. One-way ANOVA in Minitab leverages Tukey's and Hsu MCB methods for comprehensive mean comparisons across groups. Basic concept of ANOVA. The manager of metal industry would like to determine if any of 5 different processes for assembling components results in higher productivity per hour and/or in fewer defective components. ANOVA illuminates whether different assembly processes in metal industries influence productivity or defect rates. We use a 2-sample t-test to compare 2 population means. Comparing means across more than 2 populations requires advanced statistical methods beyond a simple t-test. ANOVA steps in to compare means across multiple populations, facilitating broader research inquiries. One-way ANOVA extends the 2-sample t-test to analyze variance across groups with a categorical factor. To perform an ANOVA, you must have a continuous response variable and at least one categorical factor with 2 or more levels. Understanding the difference between 2-sample t-tests and ANOVA is crucial for appropriate statistical application. A 2-sample t-test is ideal for comparing 2 group means. For example, you want to compare the daily sales for 2 different designs of web pages for your internet business. ANOVA broadens the scope, allowing comparison of means across multiple groups. For example, you want to compare the 4 different paints which claim having the same drying time. Minitab software provides a user-friendly interface for conducting complex statistical analyses like ANOVA. To study the effect of temperature on yield in a chemical process, 10 batches were produced at each of 3 temperature levels. The results follow. Construct an analysis of variance table. Use a 0.05 level of significance to test whether the temperature level has an effect on the mean yield of the process. Hypothesis testing in ANOVA determines if significant differences exist between group means, guiding research conclusions. The null hypothesis will be that all population means are equal. The alternative hypothesis will be that at least 2 of the population means are not equal. Probability plots in Minitab assess data normality, a prerequisite for reliable ANOVA results. The data points are relatively close to the fitted normal distribution line. The p-value is greater than the significance level of 0.05. Therefore, we fails to reject the null hypothesis that the data follow a normal distribution. Use a test for equal variances to test the equality of variances between populations or factor levels. Many statistical procedures, such as analysis of variance, ANOVA, and regression, assume that although different samples can come from populations with different means, they have the same variance. Choose Stat ANOVA a test for equal variances. Select response data are in a separate column for each factor level. In response, enter 40 degrees C, 60 deg C and 80 degrees Celsius. In options, select Use Test based on normal distribution. Click OK. In this summary plot, the p-values of 0.084 is greater than the significance level of 0.05. None of the differences between the groups are statistically significant, and all the comparison intervals overlap. The variants are equal between 3 groups. The one-way ANOVA procedure in Minitab is streamlined for efficiency, facilitating straightforward data analysis. Choose Stat ANOVA one-way. Select response data are in a separate column for each factor level. In response, enter 40 degrees Celsius, 60 degrees Celsius and 80 degrees Celsius. Tukey and Hsu MCB comparisons in Minitab offer detailed post-hoc analysis, identifying specific group differences. Click the Comparisons button, then select Tukey and Hsu MCB. Under Hsu MCB, select Largest Mean is Best. Click OK in each dialog box. Residual plots in Minitab provide diagnostic checks for ANOVA assumptions, ensuring accurate results. Click the Graphs button. Under Residual Plots, select 3 in 1. Click OK in each dialog box. ANOVA tables summarize the variance analysis, offering a snapshot of the data's statistical significance. The F ratio in ANOVA compares between group to within group variance, indicating the presence of significant differences. A significant F ratio suggests notable variance between groups, pointing to potential differences in mean values. In ANOVA, we compare between group variation to within group variation to determine between groups exist. If the between group variation is small relative to the within group variation, there is little evidence that the population means differ. On the other hand, if the between group variation is large relative to the within group variation, evidence suggests that the population means are not the same. ANOVA tables break down variance into components, aiding in the understanding of data distribution and group effects. SST is the total sum of squares of differences of each observation from the overall mean. SS treatment is sum of squares of differences between each subgroup mean and the overall mean. SSE is sum of squares of differences between each observation from its subgroup mean. A p-value less than 0.05 in ANOVA indicates significant differences between group means, guiding decision-making. This result indicates that the group means are different. R-squared adjusted and R-squared predicted. R-squared measures the proportion of variability in the response explained by the equation. R-squared is the proportion of variability in the response explained by the equation. The model explains 38.35% of the variation in the response. Use R-squared to determine how well the model fits your data. The higher the R-squared value, the better the model fits your data. The R-squared should be used with caution, since it is always possible to make R-squared large by adding enough terms to the model. For example, the 3-predictor model will always have an R-squared that is at least as high as the 2-predictor model. The advantage of adjusted R-squared is that it penalizes the inclusion of unnecessary variables. The adjusted R-squared is a modified version of R-squared that accounts for predictors that are not significant in a regression model. R-squared adjusted is a modified version of the R-squared that takes into account the number of predictors in a regression model. The adjusted R-squared value will only increase if the new variables significantly improve the model's performance. Use R-squared, predicted, to determine how well your model predicts the response for new observations. Models that have larger R-squared, predicted, values have better predictive ability. Multiple comparisons tests. Please select Tukey and Hsu MCB method for pairwise comparison. Tukey's method is the most powerful test when doing all pairwise comparisons. On the other hand, Hsu MCB method is the most powerful test when you compare the group with the highest or lowest mean to the other groups. What is Tukey's method? Tukey's method is used to create confidence intervals for all pairwise differences between factor-level means while controlling the family error rate to a level you specify. Multiple comparisons conducts an analysis of all possible pairwise means. 3 possible pairwise comparisons, which are 60 degrees Celsius to 40 degrees Celsius, 80 degrees Celsius to 40 degrees Celsius and 80 degrees Celsius to 60 degrees Celsius. If an interval does not contain 0, the corresponding means are significant different. There are significant difference of mean between group 60 degrees Celsius and 40 degrees Celsius as well as between group 80 degrees Celsius and 40 degrees Celsius. What is Hsu MCB method? Hsu MCB compares each group to the group with either the largest or the smallest mean, while controlling the simultaneous confidence level. 3 possible pairwise comparisons, which are 40 degrees Celsius to 80 degrees Celsius, 60 degrees Celsius to 40 degrees Celsius and 80 degrees Celsius to 40 degrees Celsius. If an interval has 0 as an endpoint, the corresponding means are significantly different. From the interval plot, the mean for 40 degrees Celsius is higher compared with other two groups. Residual analysis. Residual analysis is the primary tool for determining whether the assumed regression model is appropriate. The deviations between the actual and predicted values are called errors, or residuals. You should examine residual plots and other diagnostic statistics to determine whether your model is adequate and the assumptions of regression are met. If your model is not adequate, it will incorrectly represent your data. There are three assumptions of error which are normally distributed: constant variance for all fitted values and random and independent over time. To confirm that the analysis is valid, verify all assumptions about the model error term. In summary, one-way ANOVA, or analysis of variance, is an extension of the two-sample t-test. To perform an ANOVA, you must have a continuous response variable and at least one categorical factor with two or more levels. Tukey's method is used to create confidence intervals for all pairwise differences between factor level means while controlling the family error rate to a level you specify. Hsu MCB compares each group to the group with either the largest or the smallest mean, while controlling the simultaneous confidence level. Would you kindly consider liking and subscribing to our channel? Your support means a lot to us.